Well wishes, my friends. Today, in this topic, we learn a little about reflection of light. In the previous section, we have learned about what is light, what are the different natures of object and image, and what is reflection. Okay, the bouncing back of a ray of light in the same medium on the same side is known as reflection of light. Okay, this was the basic definition of reflection of light. Now let us see how reflection takes place. For reflection, we need to have a surface that is able to reflect the light. That surface could be anything, any shining surface. It may be a mirror, it may be a wall, okay, or any such kind of plane surface. So do only plane surfaces show the reflection of light? No. Whether the surface is plane or it is spherical or it is parabolic, or even if it is a rough surface, reflection of light is definitely taking place. Now let us see how the reflection takes place. You can see in this diagram, this is a reflecting surface, this one, okay. The reflecting side, this is the reflecting side, this is the non-reflecting side. We always indicate the non-reflecting sides by drawing these small lines. So these small lines indicate the non-reflecting part, while the opposite part, this part, it shows the reflecting surface. Now, what exactly happens is this: the incident ray comes towards the surface and then it bounces back. The ray coming towards the surface is known as incident ray, and the ray bouncing back is known as reflected ray. Okay, and this is, I already told you, this is reflecting surface. Now what is this particular line? N dash. What does this line show? This line, see, we always have to draw this line from the point at which the reflection actually takes place, and this line should always be perpendicular to the reflecting surface. Clear? Whenever you want to draw this normal, you have to take care of two things. One is that it should be normal to the reflecting surface, it should be perpendicular to the reflecting surface, and it should be drawn at the point at which the incident ray meets the reflecting surface at the point of intersection. It must be drawn at the point of intersection. What do we call this line? We call this line as the normal. Okay. So this is the basic of how reflection is taking place. Now, because this reflection is a particular, it is a phenomena, and there are some laws associated with this phenomena. What are those laws? The reflection is governed by two very simple laws of reflection. The first law says that incident ray, reflected ray, and normal, they will lie in the same plane. They lie in the same plane. Now, what is the importance of this law? See, when light emerges from anything, does it spread in a single line, or does it spread on a plane, or does it spread in three-dimensional space? Obviously, light spreads in the three-dimensional space. So, whatever work we are doing, whatever diagrams we are drawing, are we drawing three-dimensional diagrams? No, our notebooks are two-dimensional. So, how is it possible that we can draw a two-dimensional diagram for a three-dimensional surface. This law permits us to draw two-dimensional diagrams for a phenomena which is taking place in three dimensions. Now, more than this, there is no importance of this law other than this, that it is just permitting us to draw the ray diagrams in our notebooks. Okay, what is the second law? Second law says that angle I is equal to angle R. Now, what is angle I, and what is angle R? Okay, now you can see, again coming back to the diagram, you can see the incident ray and you can see the normal. So, the angle which I am drawing now, this is angle I, we call it angle of incidence. It is the angle between two lines. Which two lines? Incident ray and normal. Okay, and the another angle which I am drawing now, this is angle R. Angle R is between which two lines? It is the angle between the normal and reflected ray. So, the second law says that both the angles are going to be equal always. In any case, whether the surface is plane or rough or whatever the condition is, but these two laws of reflection are always followed. The first law is not mathematical in nature, but the second law has its own mathematics. It deals in angles. So, if angle of incidence is 40 degrees, what is angle of reflection? It will be 40 degrees. If angle of incidence is 55 degrees, what is angle of reflection? It's again 55 degrees. Now, after learning the laws of reflection, remember the laws of reflection are always followed, whatever is the type of surface, whether the surface is regular or irregular. Now the question arises that how does reflection takes place for rough surfaces, that means uneven surfaces that are not exactly plane. And the question arises that why some surfaces, they appear to be very shiny while the other surface do not shine that much. It is also because of reflection of light. See, in case of a plane regular surface, you can see this is a regular surface, a plane surface, and the rays of light, ray number 1, 2 and 3. Take your eyes towards the incident rays, the rays that are coming towards the surface. These are called 1, 2 and 3. They are reflected from this regular surface, and after reflection, are they going in same direction or different directions? All the rays of light are going in the same direction. So, this appears to be shining. So, regular surface or polished surfaces always are shining surfaces. Now, coming to irregular surfaces. Now, you can see this surface. It is irregular. Irregular means it has many ups and downs. Again, notice the rays coming towards the surface, the incident rays 1, 2 and 3. Now, when these rays strike the surface and when they bounce back, they are again named as 1, 2 and 3. You can see. Okay. Now, the question is, all these rays, the reflected rays 1, 2 and 3, are they moving in same direction or they are scattered in different directions? They are actually scattered in different directions. So, because the rays of light get scattered, the surface does not appear to be shiny. The same thing happens with metals. If you polish the surface of metal or the surface of wood, it starts shining. The same thing happens with your shoes also. When you polish your shoes, they appear to shine. Why is that? Because uh, when you have not polished, the surface has got dust in it, which makes the surface uneven. And when you polish the surface becomes smooth like this. The surface becomes regular. And so the shoe will shine. The same thing is also used in makeups. If your face is polished, it is shaved properly, it is going to shine. Okay, so this was regular and irregular reflection. Now, a little study about the plane mirror. See, this is the diagram of the plane mirror. The vertical line that you see, it represents what? It represents the plane mirror, and you can now distinguish between its reflecting and non-reflecting surfaces. Which is the non-reflecting surface? Which are having some small lines, that is rough, and the opposite one is smooth. Now, there is something you can see, that point O. What is that point? Because the rays of light are coming out, that point is what? It is an object. And now just see how the rays of light are behaving after they fall on the mirror. After falling on the mirror, they are diverged. They are moving in different directions. This ray moves this side, the second ray moves on the upper side, the bottom side. And these rays of light, do you think they are going to meet in forward direction anyway? If we extend these rays, it will be extended like this, it will be going like this. So they are never going to meet in forward direction. So what do? That we extend these reflected rays backwards. This is the reflected ray. I have extended it backwards. This reflected ray is also extended backwards. And when the point at which they meet, what is the point at which the rays of light meet? What it is called? It is called the image. Now, if the rays of light are meeting in forward direction, then the image is real. But here in this case, they are not moving, they are not meeting in forward direction, they are moving in backward direction. So the image formed now, it is what? What kind of image? It is virtual image. So a plane mirror always forms what type of images? It always forms virtual images. A plane mirror will always form virtual images. There are few more characteristics of this image which is formed. See, if you take a spoon and you look at the concave side of the spoon, then it appears the image that you see, it is inverted image. Inverted image is what? Inverted image is always the real image. And now if you turn the spoon on the other side, the image appears to be straight. Straight images are what? Straight images are always this kind of images, virtual images. So one thing you can do to differentiate between a real image and a virtual image is that if the image appears to be erect, it is what? Erect image. It is virtual. And if the image appears to be inverted, it is real image. Okay. Now there is a question given to you. In that question, a bit difficult question. It is a thought-based question, not depending on mathematics. The question says that if the mirror is turned by a certain angle, what will happen to the incident ray and the reflected ray? Let us come to the next diagram. You can see in this diagram, concentrate on the incident ray, the reflected ray, and the mirror. Now, which mirror you have to consider? You have to consider the blue lines in this. Okay. So what I am telling you to concentrate upon, this incident ray, this mirror, and the incident ray comes like this, and from this mirror it gets reflected along this line. This is angle of incidence, this is angle of reflection. Okay. Now if I am turning this mirror by, say, angle theta towards this side, I have turned this mirror a little anti-clockwise by an angle theta. What happens? The normal also turns by an angle theta. What is normal? See, normal is always attached with the mirror. So if the mirror is moving by an angle theta anti-clockwise, the normal will also move by an angle theta anti-clockwise. But the path of incident ray remains the same. So previously you have checked what was the incident angle. It was angle between incident ray and normal. That was this angle. But now this is the new normal. So what will be the angle of incidence? This will now be the angle of incidence. Got it? And what about the angle of reflection? This will be the angle of reflection. And you know, angle of incidence is always equal to angle of reflection. So incident ray, the path remains same. Mirror is turned by angle theta. Normal also turns by angle theta. So what will be the new angle of incidence? The new angle of incidence will be I plus theta. Okay. What will be the new angle of reflection? According to the laws, whatever is the angle of incidence, the same is the angle of reflection. So what is the angle of reflection? Angle of reflection will be R plus theta. Okay. So previously what were the angles? Previously the angles were I and R. That is previous. And now what happens? The angle of incidence is I plus theta and R plus theta is the angle of reflection. So by how much angle the incident ray gets shifted? Incident ray by what angle gets shifted? This is the question. See, the incident ray gets shifted by this much angle theta as well as this theta, 2 theta. Got it? So let us take it mathematically. Say previously if the angle of incidence was 40, the angle of reflection will also be what? It will be 40. Okay. Now if the angle of incidence changes by a degree of 10, the angle of reflection will also change by a degree of 10. So what is the total change in the path of light? The total change in the path of light will be 10 plus 10, 20 degrees. Okay. If you have some flexible mirror or mirror attached with some almirah, you can try it at home also. Okay. That's all for today.